All right, we are starting on 10-1, Circles and Circumference today. So that might seem a little bit weird given that on Thursday last week we were working on taking the Chapter 8 test. So we are skipping Chapter 9 for now. Chapter 9 is a chapter that we do by project, and I'm hoping that I will be able to work on that with you guys in class when we come back, rather than trying to do it this way, though depending on how things go, we may need to still do that eventually as well through this kind of lesson or something like that. So for now, we're skipping over to Chapter 10. Has nothing to do with Chapter 9, so there's nothing that we're going to miss by skipping over. So Chapter 10 is on circles, circles and circumference. Different things with circles like segments and circles and things like that come later in Chapter 10. For today, just circles and circumference. I think for the most part, for most of you, this is going to feel at least mostly like review. So a circle by definition is the set of all points equidistant a given point. That given point is called the center. So if we have a circle, we'll see how well I can do with it. Not too bad. So we have a circle and a center for the circle. And if we go from the center to the side of the circle, or a point on the circle, no matter how we do that, if we go from the center to where I drew, or the center to any other point on the circle, if it's a straight segment, that is going to be the same distance. And that segment does have a name. It's called the radius. As we go, if I don't spend enough time on a slide, you can always pause to take some notes. Something I missed as well is I would strongly encourage you to actually take notes just like you would if this was an in-class presentation that I was giving you, and just to go ahead, do it exactly the same. More or less, these lessons I plan to be very similar to that. The only exception is that it's going to be tougher for you to ask questions during the lesson, but you will be able to go back and replay it as many times as you need. So I do encourage you to still take the notes as we go. As we talked on the last slide, a radius, plural radii, is a segment with endpoints at the center of the circle and on the circle. So I showed that in the last slide. And then the formula for radius is the diameter divided by 2, or you can say the radius is 1/2 the diameter. So a diameter then, if we don't know already, and if we have a circle, not terrible, but not my best circle probably either. We have our radius, and we have a diameter. And as you can see, the diameter has points on the circle going through the center of the circle. It is made up of 2 radii. And so a radius is 1/2 of the whole diameter. So this whole segment, the whole green segment there, is the diameter. It's made up of 2 of the radius. So again, 1/2 of the diameter gives you the radius. So diameter specifically is a chord that passes through the center of a circle, as shown on the last slide. And the formula for diameter is D equals 2R. The diameter is 2 times the radius. You might ask yourself, what is a chord? Because it has not yet been defined. A chord is a segment with endpoints on the circle. So far, my worst circle. So we have a chord. It has endpoints on the circle, and that is all that we need. Going back then, a diameter is a special kind of chord that it specifically is a chord that goes through the center of the circle, right? So not every chord has to go through the center, but if it's the diameter, then it will go through the center. A Two other things that we need to know about circles. So two circles are congruent if and only if they have the same radius, that their radius measure is the same. All circles are similar. Again, when we say similar, we mean that they all have the same shape, right? So all circles have the same shape. Maybe makes even more sense than saying that they're all similar. And then concentric circles, an example is on the bottom of the screen here. They have the same center, and then two different circles that go out from that center. So just the radius is different for them. Circles can intersect in different ways. They can intersect with 2 points, as shown in the leftmost boxes. They can intersect at 1 point, and given two different ways that they can do that in the middle. And then they can intersect at no points. There's two examples there. I'll add a third example of circles intersecting with no points. So it would be just like that. The example that they give kind of like that in the box there are concentric circles. So I just want to make it clear that to have no points of intersection with one of the circles inside, they don't have to be concentric. They can be, but they don't have to be concentric. The circumference is the distance around a circle. Think about that as like a perimeter. So the perimeter of a square is the same kind of thing as the circumference of a circle. The way we find that is circumference equals 2 pi r. We can also use the diameter. Circumference equals pi d. Again, d is equal to 2r. So these two are just a substitution of each other, but they're the same thing. This leads us to what we spent our pi day on. So what is pi? What is pi? Pi is the ratio in a circle where pi equals the circumference over the diameter. So this is pi equals the circumference over the diameter. That's in any circle. So if you take the measure of any circle's circumference and divide it by the diameter, you will get pi, roughly 3.1415, right? And you can do that with any circle. At one point, that was one of the ways that they found estimations for pi. However, it's difficult to be very, very accurate with it, given that you have to have a very accurate tool to measure the circumference and the diameter, which can be a little bit difficult, which is why the ways that were described on Friday in the video we watched are actually a little bit more helpful for us, because they converge to pi and actually are much, much more accurate for us. Inscribed, polygon that has all vertices on a circle. Circumscribed is a circle where all the vertices of a polygon are on the circle. So if we have a circle, that looks pretty good. And if we had a triangle on the inside of that circle, we would say that the polygon is inscribed in the circle. We would say that the circle is circumscribed about the polygon. The circle goes around the polygon. The polygon is all inside, where each vertex is on the circle itself. All right, so some examples here. For exercises 1 through 7, refer to some symbol P, right? And that symbol we have there is our symbol for circle. So this is refer to circle P. So again, just like we have names for all of our other shapes, all of our other things, this is how we name the circle. The circle's name is based on the point of its center. The center of this circle is P. So the name of this circle is circle P. It says to name a radius. We actually have 3 different choices here. So one of our choices would be segment PC. We then have two other segments that work for a radius. We could have PA or PB. Just as a quick note, if this were in a homework assignment and it says name a radius, you do not need to name the three that I have here. You would only need one of those three. It wouldn't matter which one you have. Unless it would say something like number 5, name a radius not drawn as part of the diameter. In that case, the only choice that you have would be PC. Right? Sorry to jump around a little bit, but I just want to make that clear on what it asks there. Name a chord. A chord would be segment DE. So showing from the other side, right? This is a segment that has endpoints on the circle. And that's all it takes. So that's DE. You could also call it ED, right? We know that those are the same segment. There are also two other things that we could call it. So we can call it, not other things we can call it, but two other segments that work. So AB is a chord. It's a specific chord. This is the diameter, but a diameter is a chord. Or we could use BA. Right? Again, it says name one, name A, so you only have to name one. To go back for the radius, you could also have segment CP, segment AP, segment BP, right? To be the radius, we don't have to start with the center. We can start with the point that's on the circle as well. All right, again, we named the radius not drawn as part of the diameter. We called it PC. Again, you could also use segment CP. Suppose the diameter of the circle is 16 centimeters. So the diameter is 16. There'd be another way of saying that AB is 16. Find the radius. When it says find the radius here, it doesn't mean to name a radius. It means to find the length of a radius. And we know the radius is half the diameter. So the answer would be 8 centimeters because 8 is half of 16. Number 7 is a similar question. Here it says that PC is 11. Find AB. Well, PC is the radius or a radius. AP is also a radius, which means it must also have a length of 11. PD is also a radius. It must have a length of 11. And so make sure we use this for the right measure here. AB is 22 inches. I'm jumping all around here. I apparently missed number 4. Number 4, name a diameter. We did talk about it. That's AB, or you could say BA. Sorry about that. The diameters of circle F and circle G are 5 and 6 units respectively. Find each measure. We're going to take a second here because there's a word here that I don't know that most of you know, and that's the word respectively. I say that not because I don't know if I don't know if you know it or not, but from my experience, most students don't know what that word means. An easy way to kind of think about it is it means the way that they're giving us the information is the order that they're giving it both times. So when it talks about circle F, the first thing it talks about is 5 units. The second thing it talks about is circle G, and that's talking about 6 units. So the diameter of F is 5 units. The diameter of circle G is 6 units. There is somewhere else that you might see this sometimes, which would be in a sports article. Every once in a while, they'll say, I can't think of some people's names, players A and player B scored 12 and 15 points respectively. Means that player A scored 12 points, player B scored 15, right? So you will see that every once in a while. It doesn't come up a lot, but that's what it means. So find each measure. We want to find a measure of BF, this tiny little segment here. Right? This tiny little segment here. Okay, so we know that the length from B to G is 3 units. Right? The diameter of G is 6. From B to G is the radius, and that's half. Right? The same that GC is also 3 units. Next, we know that FG is 2 units. F is the center, G is a point on the circle, and I don't know why I said 2 units. It is clearly 2.5 units, because the diameter for F is 5 units. Half of that is 2.5, right? So BF is just 3 units minus 2.5 units, which is 1/2 unit, or units. I guess 0.5 unit or units. I guess you guys can comment and let me know if I'm wrong. I'm going to call it units. It's probably unit. All right. Some of that we probably still need, but for now I'm gonna erase all of it, and we'll add back in what we need. So we're looking for AB now. We could have kept that stuff up there then, right? So AF we know is 2.5 units, right? Because AF is the radius of circle F. The diameter is 5, so half the radius is 2.5. We already found that BF, this little bit here, is 0.5, right? That's this bit here. And therefore AB must be the whole part, 2.5, minus that little part that we know, and we find that that's 2 units. All right. You need to look at it a little bit longer. Make sure you pause it. Find the diameter and radius of a circle with the given circumference. Round to the nearest hundredth. All right, so rounding to the nearest hundredth. We know that the circumference equals 2 pi r. And we also know that circumference equals pi d. Right. So we are going to use these two things to be able to solve, and then hopefully we'll come up with an easier way that we don't have to do it every time for both of them, right? So for the first one, the circumference is 36 meters. It equals 2 pi r. To find r, we divide both sides by 2 pi. Remember, pi is just a number, even though it looks weird. It is just 3.1415 and so on, right? Hopefully a few of you remember more than that. And, oh, interesting. Hopefully you have a calculator and you do this calculation at home. And if it helps you at all, Mr. Poppy made a mistake already. So if you come up with an answer like 56.54 or 55, you're wrong, right? The radius here is not bigger than the circumference. What you need to do is make sure that when you divide by 2 pi, you actually divide by 2 pi, and you don't divide by 2 and multiply by pi. So how you want it to look in your calculator would be 36, then you have the division sign. You want to put that denominator in parentheses. Again, otherwise, if you don't put it in parentheses, your calculator is going to read it like 36 divided by 2 times pi and give you an answer like 54 or 56. If you do it the other way, then you are looking at 5.73. All right? And if we're looking at the diameter, then we have 36 equals pi d. All we have to do is divide both sides by pi. 36 divided by pi gives us about 11.46 to the nearest hundred. We should probably go back and put on our units, and we have meters for both of those. All right, we'll do number 11 together here, and then I'm going to have you do 12 and 13 on your own. So we're going to talk about a different way to kind of think about this. There's something you should recognize that we already used that might be helpful in making these problems a little bit easier. So we have number 11. If we wanted to find the diameter first, there's a reason I picked the diameter first. We would have circumference equals pi d. The circumference is 17.2 feet. That's equal to pi d. Why do I pick the diameter first? Because all I have to do is divide by pi, which is slightly easier than dividing by 2 pi. You can't make the mistake that we talked about a minute ago. We take 17.2 divided by pi, and we get that the diameter is about 5.47, and we're in feet. The radius is about half of that, right? The radius is half the diameter, so we don't have to use the formula we used on the last one. We can just divide 5.47, 493 divided by 2, and we get about 2.74. And that problem would be done. All right, so I'm going to give you a moment to work on the last 2 problems, and then I'll have the last 2 worked out. So you should press pause now to work through the last 2 problems here, and then shortly after your pause, the answers worked out should be up. All right, so hopefully this is what you got. Now, there's something weird that happened on number 13, and I'm hoping that you caught it in your original work. Now, what happens is that with the division by 2 and everything else like that, we actually get that the diameter and the radius don't look like they're half of each other, or twice and half, right? And that has to do with the rounding. The correct answer still should be what I have here, 1.59, and I forgot my units, yards, and 0.8 yards. Again, it's not half of, but we did take half to get there, right? So hopefully we did round correctly there, and I missed my units over here as well as centimeters. All right? Find the exact circumference of each circle. The first one here, so if we have this drawn in, what we may or may not know, but it is true, so I can tell you now, that this is in fact a right triangle. To draw in a diameter like this, we do need a right triangle. So we have 3 centimeters, we have 3 centimeters, and we can use the Pythagorean theorem. 3 squared plus 3 squared is the diameter squared, which is 9 plus 9 is 18. A squared, square root of both sides. 18 is 9 times 2. The square root of 9 is 3. So we have 3 root 2 equals d. Now, before I started working on that problem, after I said it was a right triangle, if you looked at it and said, hey, wait a minute, we don't need to do all of that work, Mr. Poppy, because if that's a right triangle and it's isosceles, then these two angles must be congruent. That means that this is a 45, 45, 90. And if one of the legs of a 45, 45, 90 is 3, then the hypotenuse must be 3 root 2 by the properties of a 45, 45, 90 triangle that we already know. Good for you. I'm glad you remembered. If you didn't, that's okay. Obviously, I did start with the Pythagorean theorem, which works as well. But you could have also used a 45, 45, 90. Right? Press pause, take a look at the second one on your own, and again, once you're done, unpause, and I will work out this one. All right, so hopefully you did pause and actually work it out. I can't actually prove whether you did or not, but given that this is a rectangle, we have 8 feet. I didn't even do what the directions asked me to on the last one. All right, that's okay. We'll go back to it. We have 8 feet, so if any of you were wondering why we stopped at finding the diameter, because Mr. Poppy didn't read the directions, and that happens often enough. All right, we have 8 feet, we have 15 feet. We want to find the diameter. So again, the Pythagorean theorem, 8 squared plus 15 squared is the diameter squared. We have 64 and 225. So that is 289 is d squared. We want the square root of that. Circumference is pi d. So we have pi square root of 289. As I mentioned, didn't read the directions for the first one. So we have 3 root 2. Circumference equals pi d. So the circumference is d, which is 3 root 2 times pi, 3 pi root 2. Okay. I didn't check to see if 289 was divisible by anything. My initial thought is that it's not. If it is, again, like on the other one, if I make a mistake, just make a comment somewhere for me, and I'll go back and take another look at it. All right? Homework is on page 701, numbers 10 to 13, 18, 19, 24 to 32 evens. So just the 24 to 32 is even. 40 to 42, that's 40, 41, and 42. That will be due tomorrow at noon. I have a different video that will be posted that will give you ideas or different places that you can get help if you need it before that time. So that is all that I have.